Welcome to part 3. So we're gonna continue where we left off. Okay, we didn't call the destructor here, so let's call the destructor here, that helper function. And then remember delegation. This is how you delegate. You're gonna say underscore render, and then dereference, and then you access. What do you want to access? I want to call the draw function. And then remember, if you remember our renderer.h, not our renderer, yeah. So our renderer.h, if you remember it, is supposed to take in a type, a value of type UJ_image, basically an object. So, but it's gonna take the address of that object. So I need to pass an object. So how do we pass the object? How do I pass myself, basically? Remember, this operator means the address, and I need to pass myself. So I pass the object, I dereference. I go to the address, and then I get back the object. Then it's gonna work with the object and get the address of that object. So let's read from the text file, right? So file can be a file name, right? Some file name, right? So I also need to work with, since now I need to work with files, I'm gonna include a file stream. I'm gonna include the f stream because I want to work with the file stream. I want to work with file. I want to deal with files basically. So the way it's interpreted when you are loading from a text file, you're basically getting input, but it's called a file input. So I need to create a file input object. So how do I do that? I create a if stream object and then input, call it input. And then this is going to be part of the standard library. So at the top, the very top there, I need to specify that using standard if stream. And then I'm also going to use standard of stream because I need to write to the file. When you're writing to the file, it's regarded as output. So O stands for output in this case, I stands for input, F stands for file. So input file, so I'm inputting data from the file. That's what if stream means, input file stream. So let's read data. So after reading, I need to close the file. So .close. I need to close the file. And remember what it said, closing the file. Remember any file, the way we navigate the file manager, right? You open the file, right? Like this. There's the file, you open the file. So the same thing that I'm doing there, there's a function for it to control my Windows operating system. For it to do that, I use an instance of an input file stream, and then I say .open. So this open function, I'm telling the computer to open a file. What is it called? init_large. So it's gonna do this. It's gonna open it like this. So let's do that. What's the file? Some file name. So it's gonna read some. It's gonna be some file, and then I need to make sure that this file, I was able to open it. Yeah, I need to make sure there wasn't any issues. So I used the if input.fail, if it failed, in whatever way it failed, if it failed in any way, I need to output an error. Failed to open file. And then I put an end of line character, and then I exit the program with error in file open. Error in opening the file, basically. And then, yeah, check if the file failed to open. And then here, open file. And then after opening the file, now I want to read from the file. So the way I'm gonna go about doing it, we're gonna use a string stream, but we don't have, okay, we don't have to be too, the first thing that we're gonna read is these 3 values. Remember, they say this is a rows, this is a column, and then this is stochastic. It's either yes or no. In this case, it's a yes. So I'm gonna have stochastic, right? So let's read the rows and columns. So the same way you use cin to read in values. And remember the way cin works. It reads the next value after the space. If you don't believe me, let's see for ourselves. So AB, right? So cin, read A, read the first value and store it inside the variable A, and then read the second value and store it inside the variable B. So I'm gonna say cout A, and line, and then cout B, and then end line, and then you're gonna see, okay, I hope I don't have any other errors. Okay, I don't want to work with this yet. Default pixel. There shouldn't be any issues there. So let's debug. Let's build it again. Const this regards disqualifies binding reference type to const. Oh, okay. That's what I was avoiding. I thought about it, but yeah. So it's the issue of the address. So we need to remove the address. So in our case, in this case, you don't have to take it by address. So I'm going to change those 2 things. And then I need to remove this. And then, oh, okay, I remember. Okay, the helper function, it takes in all 3 arguments. So we also need to provide the default pixel. So I needed to fix that. Obj image was not declared. Oh, okay, yeah, it's true. It wasn't declared. So I need to change it to obj right-hand side because this is my right-hand side of the operator. So I need to change that to obj right-hand side. Okay, so I'm supposed to do this to allocate the size to use the object itself and get the size of that object. That's why it was complaining. Okay, I wasn't trying to do anything like that. Yeah, there's a lot of things that I had to change. Should be fine now, so we're good to go. So let's build and run. So let me show you what I meant. So there's the 12 space, then there's the next available integer. You see, it takes both of them. So I'm going to use that same concept to read the file. So when you read the file, the first 2 values are the rows and columns. So, and as I was saying, it works the same way as cin because I'm getting input, right? But then this is input. This is a different type of input. This is input from a file, not from the console. Remember what cin means. It means console input. In stands for input. Or you can call it character input. That C stands for character or console input. So I'm getting input via the console, or I'm getting input of characters. It can be any character. It can be an int, double, whatever. you want to call it. So let's do this. Let's use the same concept, right? So the very first two things, the very first value, I know it's a row. It's the number of rows. Then the value after that is the columns. And then the value after that, remember we store remember we have, is it underscore store? What did I call it? Stochasticity. Yeah. Remember the next thing that we're going to take in is the stochasticity, which is that character. So the way it reads this is going to read 500 and then put it into these rows. After the space, read the next available integer. Because remember, after this, it sees a space like, oh, that's where this rows and this integer ends, and then it stores it here. After the space, we have another 500. It's going to read the next available integer, or it starts here, and then, or it ends there. Then it stores the 500 into columns. Then there's a space, and then there's the character y. And you can see it's one character, so it's going to check, oh, it's y. Where does it start? Oh, it's the only one. So it stores it into stochasticity. So now we are done doing this. Okay, I'm also going to need to use the string stream. So I'm going to say using, okay, I already said using standard string stream, the string stream from the standard namespace. And then there we go. Now I need to read, right? So I'm going to use a very useful function, because if you check this data, right, the first two values is the row and the column. And then this is the array. But then if you check the array values, they are not of the same size. If you check, they are not of the same size. Sometimes I have all 5, sometimes I have only 2. So the way I'm going to go about checking how many values I have, it's very simple. I'm going to get the line. I'm going to get each line. And then that line, I'm going to put it into a string, store it as a string, and then put it into a string stream, and then read one value at a time. So let's do that. So string, I'm going to store the line, then initialize it. Okay, I'm going to use the brackets to initialize it. As you can see, it's going to work. I'm going to use the brackets to initialize the string. You can check documentation on the textbook to understand a bit more on that. I won't touch on that topic yet. So we have the string stream, and then I have the variable line of type string. So I'm going to say while get line. So while this get line function is able to get the line from what? This file, from this file, and I reference the file via the input file stream object. And then I get that line and store it inside this string called line. And then now I push that string into a string stream, because remember what I want to do. Remember, I'm going to have values like this. I want to push it into a string stream and then read one value at a time. Read an integer. Use the same concept that I was doing here. Read it one at a time. Read this integer, and then, okay, that's the only integer, and then read the next integer. Oh, that's the only integer. And then there's the next integer. So that's what I want to do. So how do I do that? So first things first, I'm going to read the indexes, the row and the columns. In row underscore column. Initialize them to 0. Right? And then there's no need for me to keep redeclaring them. I'm just going to declare them once here on the outside. And then I'm also going to create a counter variable that starts at 0. Remember that I need to index into my one-dimensional array. So what's going to happen is that every time I'm going to set the first value that I get while I'm getting values from my string stream. Remember what happens when you get a value from the string stream. It takes an integer and then done. Then we'll be left with these 4 values. And then it takes the next available integer and then done. I'll be left with these 3 values. And then remember these 3 values that are left represent the values in my array. And the values, I need to put them in the right index, in the right position. So I start at position 0, and then I increment every time to move to the next position, move to the next position. So that's why I need to do that. So let's read the first integers. So I'm gonna read a row and a column. And then now I'm going to read the integers, right? So I'm going to create a variable called value. That's going to store the integer that I get, those integers that are left. Because remember now, this is what's going on. I've read the index and the row and the column. Now I'm left with these values. So I'm going to do a while loop and then say while it's reading an integer in my string stream. Obviously, when it reaches the end here, it stops because there's no available integer. So that's what I'm going to do. I'm going to say while it's reading an integer from the string stream, store it inside value, and then index into my pixels array in that specific row that I've received from the file, and a specific column that I've received from the file. Dot, remember, it's the seeds array that I need to change. At what index? I use counter to index, and then I say that specific position is equals to value. Because remember, I'm reading from the string stream. Really look at the direction of the arrows. The value is being taken from here, and it's being transferred to this variable. So I'm going to say is equals to that variable. And then I'm going to say counter plus plus. So now I move to the next position in my array. But I can also combine these steps and just say plus plus. Because remember what plus plus means. It means return the value, current value first, and then increment after. The current value is 0. So it's going to return 0 like this, and then add after. The next time it comes, the value is going to be now 1. That's post increment. And then I'm done. I've read from the file. That's all the code you need to read from the file. And then now, since I have the stochasticity, this value, basically, remember that we have two types of renderers. I have the stochasticity and the continuous. And they said the file contains this information. Where is it? Yeah, it contains rows and column and stochasticity. Stochasticity means it's a value that indicates whether it is a stochasticity, stochasticity it is a stochastic renderer or not. You know, if it is, then I think I instantiate an object of stochasticity. So we're gonna do that now. So let's do that. So I'm going to say I'm going to, where's the lifecycle management? Okay. I'm going to say check if stochasticity is equals to y. That means yes, it is a stochastic renderer. And then if it happens to be a stochastic renderer, then I instantiate a stochastic renderer. So render is equals to new stochastic renderer. And remember, I created a default constructor. Did we implement? Oh, I haven't implemented, so it might complain. So let's just quickly implement the constructor. Then the virtual function. Remember when you're implementing, oh, I forgot to say void here. When you're implementing the virtual function in your implementation file, you don't put the virtual keyword, or else it's going to crash. Then there's the constructor. JImage, and then there we go. And then I need to also create the continuous renderer so that when I also instantiate it, I don't have to go back and create the files. So I'm going to create this class. So create the class, but I'm going to create one file at a time. So continuous renderer.h. Wait, I already have it. I need the implementation file. I forgot to also put the void here. View, new, and then file, CPP file, continuous renderer, CPP, all, and then hash include continuous renderer.h. Then continuous renderer, it's going to have a default constructor, then void the draw function, takes in a UJ image by reference, obj image. And then now I need to chain to my base class. So with inheritance, you can chain to your base class, because at the end of the day, you inherited some features of your parent, right? So you can call the default constructor of your base class. In our case, I'm gonna call this default one because I don't care about the coordinates. So render, right? And then before we forget the destructors, so I need to create destructor. Okay, if you want, I mean, it's virtual, so it's gonna, okay, let's just override it, and you don't do anything at the end of the day because the life cycle is being managed by UJ image. It's just there. I'll just say it's like there for convention. For now, I'm just gonna put it, just gonna say that's the only case it's there, but it's gonna be called in automatically. And then continuous renderer virtual, continuous renderer, and then copy, and there we go. And then now it should be fine. I won't have any unexpected errors when I'm instantiating these objects. And then else, if it's not a stochastic renderer, then obviously something else. But we also might want to handle an error where it's neither. Stochasticity. So I'm just gonna use an else if. Let's go render is equals to new continuous render like this, and then else. Okay, for the else part, what I'm just gonna do is I'm gonna output an error. Could not instantiate a renderer. Then exit error. Okay, we're gonna have, I'll just say an error in what? It's actually it's an error in instantiation. So error in instantiation. Error in instantiation. So I'm gonna have this and then copy it. It's gonna exit that. value. So we now have the renderer. Now we need to also manage its life cycle. So I'm going to delete it here. So delete underscore render, and then also set render equal to null pointer. It shouldn't point to anything. And then everything should be fine now. We've read the file. Now we need to save to a binary file. So let's implement the save to dat file, which takes in a file name. It's exactly the same thing. The only difference is that we're using an OF string because when you write to a file, it's technically output. You're outputting to a file. So it's like output, console output, cout. You're outputting to the console. So it's the same thing. So output.close. Don't forget to close the file after using it, right? You don't want to tell the computer to open the file like this, and then it reads the file, and then you just leave it open. You don't want that. You should go there and then close the file. That's what this function does. It closes the file. It's a void function because, as you can see, it doesn't return anything. So now I'm going to open my file. So dot open what file? A file with that name, which makes sense because you can't open a file with that right name. For example, obviously I look at the file that I'm trying to open. Oh, is this one init_large? That's the one I want to open. Oh, there it is. You see, so you also need to pass the name there, or else you don't know which file to open. And you need to open the file in you can set the mode. You see, so you see there's the mode. So by default, it's an output mode. We don't have to worry about that because we can overwrite it and be explicit and say it, but we don't have to do that. So the only thing that I need to write here is that I need to say it's binary mode because I'm saving to a binary file. So I want to open it in binary. I want to open it in binary mode because I want to save this data in a binary format. And then I'm going to go through each of the pixels. So R is less than underscore rows R plus plus. Then for int C is equal to 0, C is less than underscore calls, C plus plus. And then now we write the file. It's very simple. We just say output dot, with the binary files, you can either dot read. Okay, this is an output file. It's mainly for output, so you don't show the read function. So you're gonna show the write function. So you want to write what do you want to write? So if you check your textbook, the textbook you have prescribed, it explains this concept. When you're working with binary files, the way it knows where to start and where to stop, you need to specify the information in bytes. So we can use the size of function to find the size of something in bytes. And remember, bytes, 1 byte is equivalent to 8 bits. Bits means binary digits. What are binary digits? It's basically zeros and ones. So the way it interprets that text or that information, it interprets it as a string of characters. So whatever information you need to pass, you need to convert it to a string. So I need to say reinterpret cost and then const. What is this? Const char pointer. I'm not changing it. I'm not doing anything. You should convert it in such a way that the user shouldn't change it. No one should change this information. I'm just outputting the file. And you can just write to the file or read from the file. So what do I want to convert? I want to convert my pixels, right? Add the specific row and column. But to make things faster, remember what we need to do. We need to get it by address. So this function takes two things. the information that you want to write, and you have to convert it to a string of characters. And then you say you pass the size. You see, stream size. What is this? What is the size of the thing you want to store in terms of bytes? So use the size of operate, and then you pass the thing. It's that pixel, that specific row and column. Then that's it. You always need to write this one line. And in order to read, this just turns into dot read, and then that's it. And then here you have to change it to an I, because now you're working with input. You're reading from the file. Then this is delegation. So I'm delegating my task to somebody else who's way better in this thing. Why is it complaining? You should show the error though. You shouldn't just complain. iOS was not declared. Well, these are some of the errors that you're gonna face if you don't include the whole standard namespace. But I don't want to work with all of it. So I'm just gonna do that. And then most of the errors are gonna disappear. Yes. Expected specifier before type. So what this means basically, it doesn't know what this thing is yet. So it doesn't know it, right? So since it doesn't know it, and I need to avoid secular, what is the secular thingy dependency? I already included here. And remember, whatever I included copies and paste. So for this part, I'm gonna avoid including header files, because it's gonna make my program crash. What I would do is I'll do forward declaration. So forward declaration, stochastic render, and then continuous render. I hope this fixes the problem. Okay, it doesn't fix the problem. So it wants the header file. Since I'm actually using a constructor from the class, so it needs to have all of the implementation. So let's just include all of the implementation. Continuous render. Yeah, there we go. So it needs all of the implementation. But then now it becomes problematic now, because I'm including it here, stochastic, and I'm not done defining it. Even though it's not crashing, but yeah, I mean, in a way, these preprocessor directives, they prevent that from happening. You see, they check if it's not defined, define it. It's gonna check again. If not defined, well, it's already defined, so it's gonna skip, don't define it. But then I don't want that. I want to avoid that. So what I would do is, what if I just say render dot age, right? Okay. Oh yeah, this program of mine takes inputs that side. So I have this. So we have the stochastic render. This is the UG image. It's not complaining. Let's see. Let me see something here. Render.age. Oh yeah, it does have a forward declaration of UG image. So that's why it's not complaining about this UG image. So that should be fine. But then the problem starts now when you have to implement it. So let's check. What are we supposed to do? How are we supposed to implement stochastic thingy? Overrides the draw functions to perform the draw method as described previously. And then okay, remember we called the default constructor in our base class, but this also takes a chance. So I'm going to set the chance to 90. That's the default that they used to get that image, those images, or that image. So we're going to use that. For every pixel, it must generate a random number between 0 and 9. If the number is less than or equal to the chance, the pixel must be drawn onto the image. Otherwise, a black pixel must be drawn to the image. Black pixel, let's see. And an image is drawn, the pixels must be updated as follows. The value of each color component must be set to R minus C, where R is the pixel's row coordinate and C is the column coordinate. In cases where R minus C is less than 0, the color component being modified must be set to 0. So we're gonna, okay, we forgot to read the image, the file, right? Remember they said we should read it inside the default construct. So I must call that function that reads the file. What file am I reading? It's called init_large.txt. That's the file I must read. And then everything's gonna be initialized. But then we also have a problem. So we actually need to call the allocate function here to the constructor to allocate. Because after reading here, remember I'm not chaining it to the other constructors because I don't want to chain it with the wrong values and there's no default values. So here I'm just gonna say allocate memory for the object or for the array, for the 2D array. So I'm gonna call the constructor, which takes in those rows that you just finished reading from the user. And the set by default, everything should be 0 or black. So there we go. So it also does allocate. Then here we read from the file. So there we go. Now this is perfect. So now we need to draw onto the image. And they said we should draw, it should be R minus C. And then if R minus C happens to be less than 0, we set the pixel to 0, where R is the row and C is the column. Is drawn. Oh, so that's what it means. So this is how we're going to draw. We draw based on that value. So overrides for every pixel, it must generate a random number between 0 and 100. If the number is less than or equal to the chance, then the pixel must be drawn. So we must first calculate the chance before we do this. We must find a random value, get a random value between 0 and 100. So int random. So we have int lower, int upper, which returns the rand function modded by the range, which is upper minus the lower value plus 1, and then plus the lower value, so that it starts from that lower value that was being passed by the user. So they're talking about for every pixel. So that I have to go through every single pixel. So every single row underscore that object's rows.get rows r++. And look at notice this now. I'm outside UJ image. Now I need to use the helper, the accessor methods or accessors. Because remember what this line means. It means this function is part of stochastic renderer. And stochastic renderer doesn't have a private member variable called UJ image or something UJ image. It just takes it in. UJ image is not part of stochastic, so I have to use the accessors now. And then for int c is equals to 0, c is less than obj image dot get columns c++. There we go. I have my row and column. Now I need to generate a random value. Rand value is equals to random between 0 and 100. And then now I need to check if the chance happens to be less than or equals to that random value, then I draw the image. So basically I applied this. So let's check how we're supposed to draw the image. The value of each pixel's color component. So red, green, and blue, it's set to the row, current row minus current column. So I must do this. But then I need to also check the difference. If the difference, remember to say, if the difference is less than 0, the color component being modified must be set to 0. It shouldn't be less than 0. So I'm gonna have something called change r minus c. And then if change happens to be less than 0, then you should set the color components to 0, all of them. So let's set the color components. So I'm gonna have obj image dot set pixel, that specific row, and column, then set it to that specific pixel. But in order for me to set the pixel, I need to get the pixel. So I'm gonna get the uj pixel is equals to bj image dot get pixel, the specific row and column. And then we update the red, green, and blue color components. Dot int red is equal to 0, and then pixel dot int green is equal to 0, then pixel dot int blue is equal to 0. And then now I pass that pixel, and then I set that pixel. And then if the change happens to be greater than or equals to 0, right? So that's the else part. Then I can just set all the color components to the answer or to change. So it's gonna be the exact same thing. But then I want to, okay, it's fine. If I put it outside, yeah, it's fine like this. Okay, no, let's just avoid repeating. I'm gonna declare it once outside. There we go. Then get the pixel, set the pixel. Then if it happened to be fine, positive, if the value happened to be positive, set it to that positive value. Then set the pixel. Then that should be fine. So let's just check the seed value. I think you're supposed to seed the random number generator. So the seed value of the random number generator is the sum of the seed values of the pixels. So when this random function generates values, we need to seed the values based on the sum. So, and the values are all integers. So when I say sum is equals to 0, because remember each pixel has specific, it has its own array. So that's why I'm putting it within this second for loop for columns. So we need to seed the function. Oh, okay, so we don't, let me see, do we have to set it here? Or we set it inside the header file? But it's inside the CPP file. Okay, so we include renderer. And then renderer doesn't have, this is build. Okay, that's fine. Oh, yeah, renderer doesn't have this. So I think it's fine now. After including this, I can include the UGA image because it needs to know about, okay, let's go up. Yeah, it needs to know about the functions. So I can either include it here or that side, but let me just include it here. UGA image. Yeah, now it's fine because it knows the rend function is include the ctime function is included inside UGA image. So now we need to seed the random number generator. So we need to sort of like create an inner for loop. So add, or we can just avoid the for loop because we know exactly how many numbers are there. I don't have to do a for loop. So what I'll just do is say add these values. So let's see, pixel. Let's actually get the pixel outside and reuse that value. Get it here at the top. Then now I'm going to say pixel dot pixel dot seeds index 0, and then plus seeds at index 1 plus seeds at index 2 and plus seeds at index 3 plus seeds at index 4. So I don't have to write, and I don't have to do a for loop for that. Build. Okay, I think it wants it in 1. Oh, I just forgot to put the add there. Okay, that's fine. And then we seed the random number generator. So we need to seed it every time. So seed the random number generator. So seed not srand time function taking that sum. And then we are done with the stochastic renderer. Yeah, as you can see, the following image is an example of how the output chance is an output of when the chance is set to 90, and we did set the chance to 90. That should be fine. And then now we need to do the continuous renderer. And there's no random values for the continuous render. It's just straightforward. For each pixel, it must check all of its color components and make sure that they are less than the maximum before the pixel is drawn onto the image. Okay, so we just check the pixel if it's less than the maximum. If it's just less than the maximum, draw the image. Else we don't draw. So that means it's gonna be black if it happens to be less. If it happens to be greater than the maximum. So I'm just gonna reuse this code inside of my continuous render. But there's a lot of things that I don't do inside the continuous renderer. For example, random value, setting the random number generator, finding the difference. So the logic is now different. I just want to delete this one. Okay, it doesn't delete the whole thing. I wanted to cheat it. So we get the pixel, then we start working with the pixel. So with the maximum intensity, I don't know where we get the maximum intensity, but we're just gonna use that. So the maximum intensity before the pixel is drawn, this is the following example, shows the image. It's an integer set during the creation via construct. So we're just gonna set that maximum intensity. I don't know what we're gonna set it to. Say 10, just a value. Not sure what they want you to set it to in order to produce that image. So they are less than the maximum intensity before the image can be drawn. So I'm gonna need to make sure that it's less than before I can draw. So if for all of the values, right? If it's less than, okay, let's check the previous one. For every pixel, you must generate a random number. If the number is less than or equals to the chance. Okay, so we just checked the number for that one. We generated a random value. We checked, okay, it's the other way around. It's the number is less than or equals to chance. If it's less than or equals to the chance, we draw the pixel, but in order to draw the pixel, we check if it's less than 0 or positive. So here we're checking the for each pixel, it must check all its color components. Okay, so all the color components must be less than that maximum. So pixel dot int it must be less than maximum intensity, and it says each pixel, all its color components. So all, I must use the end. If they said at least one of them, you would have used the or, but all of them need to be true. So I'm going to use the end. Blue underscore maximum intensity. Then if they're less than, then we draw the image. So now we can draw the image. So to draw the image, we must find a value. Let's say the current row minus the current column. And then you check if that value is positive. So I'm going to check if it's less than 0. If it is negative, then we set all the color components to 0. So pixel dot red is equals to 0. Pixel dot green is equals to 0. Pixel dot blue is equals to 0. And then obj image dot set pixel at that specific row and column, set it to this pixel. Else just set the color components to that change. Pixel dot int green is equals to change. Pixel dot int blue is equals to change. And then that's everything you need to do. Then now I think we can run our program and try to output the image and see if they're going to be the same. Yeah, that's everything you're required to do here. So let's try and run the program and see if we have any errors. Rand value. And just double check. invalid conversion from int to long int. Long int pointer. So let's see. Let me see if I do this. But the pointer is still there. It might not work. Yeah, it might not work. That pointer there. Underscore chance. Oh, so we're sitting with that sum, not like this. Yeah, and I shouldn't call the time function. The time function, you call it when you're using the null pointer, or you're using now from the C language. So you can call the time function. Okay, I need to put the try with this main that we are provided with. Try running it at this. Then debug if we have any issues. 256 is greater than the maximum of 255. Let's see. So gonna generate 10 plus 100 plus 60. Convert to RGB. Blah, blah, blah. Okay, so what I'm going to do is inside of my, not sure which function called this. It's -3. So there's an error in the range. So what I'm going to do is let's comment out. Okay, which range? Oh, it could be the text file. Let's check the text file. But the text file doesn't contain anything related to the pixels. It just contains the row, column. There we go. Build. Where is it getting 256? It's either it's the set pixel or the get pixel. Yeah, it's not the row, it's the pixels themselves. So that's not, yeah, that means it's either set pixel. Let's see. Okay. It's supposed to show the, when you call, oh, okay, so they add 1 to everything and then output that, then save to the binary file, you draw, you assign. After assigning, you change. Okay, let's double check our assignment operator. With the assignment operator, let's remove that const there. And then what else do we need to check? Am I outputting it properly? Okay, so you output red, then space, and then the next line you output green, space. Next line output blue, space. Then once you're done with this, once we've gone through all the columns for that specific row, we output an end of line character. Okay, and then here we add to the pre-increment. That's fine. So something is missing. Not sure if it's the data that we are reading or what. Let's check where we read the data. Okay, let's just comment out a few lines and see. Okay, let's call the draw function, and then do that. Okay, let's just output object obj image without adding, without doing anything. Okay, so it could be where I'm formatting my output. That's the only reason why it's outputting like that. So my stream insertion operator. So const output read. And let me see. So this outputs every single column, right? So it's gonna output, let's say color component 9. Then it puts a space there, outputs a value, puts a value, it's a value, outputs a value. Yeah, so the output should be fine. Output in a new line, red, green, blue, 255. Okay, let's change that to 255. Let me see if it does. At least 3, 3, 3, 1, 2. Using standard and line P3 image, and output the columns. And then you do that. Image 2. Which image, so this reads the file, also reads the file. Reg pixel is equals to the pixel set the pixel, convert to G, and set the pixel, call the set pixel function. And then UJ image, let's check set pixel function. So let's see, it's row value counter. So this is fine. Assignment operator, that's fine. Set pixel. Yeah, the way I'm setting the pixel. Yeah, I think it was a set pixel. Let's go back there. Let me not set it like that. Let me set it by value. Should build fine. Okay, that's one thing fixed. Get the pixels. This is fine. Is it init underscore large? What's the name of that file? Init underscore large.txt. Files. Renderer.h, stochastic renderer, UJ image. P3 image, blah, 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 columns, line. So this is fine. Let me do this. Yeah. It should be fine. Let me try and convert it to an image. So let me build it again. Okay, it has those values. Let me see if it's gonna output a meaningful image. CMD, then I'm gonna do the then I want the executable. So okay, I was supposed to go inside the bin folder. Debug. There we go. CD. No. CD. Yeah. Okay. CMD. Yeah. Okay, this is the executable. And then I'm gonna call it image.ppm. Computer. .exe is not found. So I don't think I think it doesn't like the spaces. And I think I just have to try compile it normally and give it a name. So let me compile it. For G plus plus. I want to compile main.cpp. Send it to an object file called main. No, oh, okay, it's not in the file. Go back to my folder. Then cmd. Then I'm gonna have g plus plus main.cpp /o, yeah, /o to main and define reference to. You just said pixel. Yeah, I think it's It's the way I named the project. That's why I can't convert it to an image. So I don't think it likes spaces. Because I tried to run the executable file and it's complaining about doesn't know computer what. So it's the spaces. So we have to look at the code, the way it's being displayed, all of the little details. It's a P3 image 255 object rows, columns. So you put a space and you put an line character, put a space. And let me try to output the image before doing every other thing. So image, then comment out this. Okay, still outputting the same. And undo. Okay, usually image, static const expression default. So from the file, I read the rows, columns, stochasticity, and then I allocate memory, initialize a string, then initialize a stream, then get the line, push the line into the string stream, extract the first two values, then read the remaining values. Enforce range. Pixel. Okay. Stochastic renderer should be fine. Okay, let me do this. Instead of including the renderer, let's include the UJ image. And then inside continuous, oh, we did include just UJ image. Okay. Get it from renderer. Get UJ pixel random value. So let's open renderer and renderer.h. Move it to the pixel. And void the draw function. And, okay, that's fine. Okay, let me test something. Let's output this inside main. And I'm just gonna say 25 by 25. 5 by 25. Then it's gonna be a row plus C. Row plus C. Row plus C. Okay, I need to say C out. C out. Build and run. Yeah, it's the format. Yeah, I think that's the way I'm formatting the date. So let's see. Output stream. Output the integer value followed by a space. Then do that. Okay, let's do this. Okay, it's now outputting in the correct. I think it's the correct form now. Yeah, there they are, those values. 111. Okay, it does print there at the top. So now we need to find a way to execute it and convert the image. There's my executable here. Let me try and copy the name. Let's see if that'll work. So CMD. Just make sure it's there. Yes, it's there. Put that into ppm. It is. Seems like doesn't like the spaces. Still doesn't like the spaces. So what I'll do is let me do this. Let's go to the project, open the individual files, render stochastic, PJ image, then open a notepad. Okay, open a notepad. Okay, the main, open it after. Then remove this one. No, I don't want to save. Then let's do this. New project, console application. Then I'm going to call it paper B 2022. So it's going to be paper B 2022. And then I'm just going to copy. Okay, seems like it doesn't want me to do that. So let's do this. Um, so let's transfer all these files to this project. So uj image.h, then all finish. Right, and then I'm just gonna copy images content here, copy, and then copy, paste. Then file uj image.cpp. There we go. And then uj image.cpp, copy, paste. Then new file render render.h, and then yeah, I don't want to be opening the same files inside code blocks. I'm just going to copy it from my notepad++. Render.cpp, then renderer.cpp, where are you? There you are. Copy, move, then my render is there. Then I need to create the stochastic renderer. Okay, let me start with continuous. Renderer.age, and then let me copy all of its content. Okay, I want the header file. CPP file. Okay, I wanted to copy the name .cpp. Then take the CPP file, code, put it there. And then I'm gonna create the stochastic render. Yeah, from now on, just make sure, however you name your project, there are no spaces, because now I had to restart the whole project. Because when it generates the executable, now the spaces, and yeah, it becomes very hard to tell whether this is still the file name or it's something else. So just make your life easier for both you and the compiler and the computer. And CPP file. There we go. Then main. There we go. then build. Yeah, it failed to open the file because in this new project, the file does not exist. So let's add the file. It's paperbead 2022. Then let's try it again. There we go. So after compiling this thing, it's going to create an executable. And then that executable, we're going to use it to redirect its answer to a file that we want to name image.ppm. Oh, so yeah, it's a it's a bit of a tricky issue. So if you want to convert it into an image, copy the folder into the file into the same folder as the executable. So that when you try to convert it to an image, remember it's gonna read the file. So it needs to find the file within that folder, image.ppm. There we go. Let's see if it did output something or my structure was actually fine. There we go. There's the image. That's how they wanted you to do it. As you can see, it is fine. Everything is displaying on the screen. It's magic, right? Yeah. Just make sure when you name your project, don't put spaces, right? Don't put spaces. It's gonna be a problem. So thank you guys for watching. Just let me know if you have any questions. That's it for today. All the best with your semester test.